Welcome. We're going to start looking at the sets of numbers. Natural number, whole number, integers, rational number, irrational number, square number, even number, odd number, prime numbers, composite numbers. So, let's go here. Alright. Sets of numbers, natural numbers. When you talk about natural numbers, when you count natural objects, you do not point to the first one and say 0. You point to the first one and say 1. Then the next one makes 2, 3, 4, and so on and so forth. When you're going to count how many chairs are in the room, you start from 1. So natural numbers start from 1. You start counting from 1. So those are natural numbers, also called counting numbers. Then, in the next set of numbers, you want to account for a situation when you don't have anything. You want something to represent nothing. So, just like with natural numbers, you start with 1, 2, 3, and so on and so forth. You have whole numbers. When there's nothing there, you write 0. Then you start counting 1, 2, 3, 4, and so on and so forth. Those are whole numbers. Then next, you have another set of numbers. It makes a count for nothing, which is 0, as well as 1, 2, 3, 4, and so on and so forth. But the thing is this. What happened in a certain situation? Example. You have the ground. You have a house. You have the window. Let's say the window is 5 meters above ground level. You consider ground level as 0 meters. But then you dig a pit, and that pit, the bottom of the pit is 6 meters below ground level. What you would have to say with reference to ground level, the pit, the bottom of the pit is -6 meters. You can say 6 meters below 0, or you could say -6 meters. So a positive 5 meters is 5 meters above ground, but a -6 is 6 meters below ground. Additionally, when you have the Celsius scale, 0 degrees Celsius is where water freezes. 100 is where water boils. But what happens when you have temperatures colder than when water freezes? You're talking about a negative, such as -5 degrees Celsius. So integers now take care of that. you're dealing with temperatures, or you're dealing with numbers in the negative range. Let's draw our number line. On our number line, you have 0 in the middle, positive numbers to the right, positive 1, positive 2, positive 3, positive 4, negative 1, negative 2, negative 3, negative 4, and so on and so forth. Positive numbers to the right, negative numbers to the left. So, these are integers. Negative numbers. Negative 3, negative 2, negative 1, 0, 1, 2, 3, and so on and so forth. So those are integers, you see. Integers. Next type of numbers we're going to look at are called rational numbers. Look at this. R-A-T-I-O. You ever did ratio before? Then we put the N-A-L on it. Rational numbers. Ratio deals with fractions. 2/3 is a rational number. You see, 1/2 is a rational number. You see, 3/4 is a rational number. Here, that's what we have. What about 5? Is 5 a rational number? Certainly, it's a natural number. It is a whole number. It is an integer. But is it a rational number too? Well, you can write it as divided by 1. So, 5 is indeed a rational number. Now, rational number can be written as one number divided by another number, as you see here. So that's rational number. We have another set of numbers. You need to add the IR before the rational. What you have is an irrational number. A popular example of an irrational number is the square root of 2. What is this irrational number? Irrational number is a number that you cannot write exactly as a whole number or decimal, or a number divided by another. No calculator, no computer can show the exact number in decimal form. Let's look at our calculator here. On our calculator, square root of 2 equal. You have 1.4, but that is not perfectly accurate. It's not exact. 1.41, that's not exact either. 1.414, more accurate but not exact. What we see here is this. We have 1.414213562, but there are other numbers going on. These numbers go on and on forever. Once you stop, it's not perfectly accurate. So this is an example of an irrational number. It is not a rational number. All the numbers we looked at so far are rational numbers. What about the square number? Now, a square. What is a square? Square is a quadrilateral, 4 sides, 90 degrees each side at each angle, and each side has the same dimension. If we consider this as the width and this as the height, we say the width and the height are the same because it is a square. Now we want to see the square numbers. The square number would be the area of the square. This is 1. This is 1. 1 times 1 gives you 1. Now imagine that we have this width is 2 and the height is 2. You see, what we have is 1, 2, 3, 4. 4 squares inside here. So 2 times 2 gives you 4. 4 is another square number. Suppose we have 3 by 3. We have 3 wide, 3 high. How many squares do we have as the area of this? What we have is this. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 squares. So 9 is a square number. 3 times 3 gives you 9. You see that? Now, here, we could have 4, and we see that 4 by 4 is 16. So these over here are the square numbers. So the square numbers would be 1, 4, 9, 16. What do you think the other one would be? It's 25. Next, 36. And so on and so forth. When you square a whole number, you get a square number. So, these are square numbers. So you see those. The next type of numbers we want to look at are the even numbers. Even. Now, let's look at this. You have a seesaw, and you see your friend Esau sitting on the seesaw. The seesaw will tilt down this way. Assuming that you and Esau are of the same weight, you sit on the other side of the seesaw and it's balanced. It doesn't tilt. So, you have an even number of persons sitting on the seesaw when it is balanced. Aha. Now, if another friend comes here and sits on the left, it will tilt down to the, on the right, it will tilt down to the right. But if someone else of the same weight come and sits here, you now have an even number 4 and it will balance. So an even number of persons will make the seesaw balance. provided that the distance they sit from the pivot is the same and they have the same weight. So the even number include 2, 4, 6, 8. Those are even numbers. Numbers that you can divide by 2 and you get an answer without a remainder. 6 divided by 2 is 3, no remainder. 8 divided by 2 is 4, no remainder. That is what you have. You have the formula 2 times an whole number will always give you an even number. So you see even numbers 2, 4, 6, 8, 10, 12, 14, 16, and so on and so forth. Those are even numbers. What about odd numbers? O, B, D. We're dealing with odd numbers now. Now, odd numbers, when you divide them by 2, you get a remainder, such as 3. 3 divided by 2 is 1, remainder 1. 5 divided by 2 is 2, remainder 1. 7 divided by 2 is 3, remainder 1. With the odd number, an odd number of persons will cause the seesaw to tilt. When you have 5 persons, the one on which 3 persons sit will make it tilt over to that side. If you have 7 persons, it's 4 plus 3. The one where you have, the side where you have 4 persons will be heavier, so it will tilt over to that side, and so on and so forth. The formula for an odd number is 2 times n, an whole number, plus 1. Alright. So 2 times any number, you can try it. 2 times any whole number will be even. When you add 1 to it, it will become odd. So those are odd numbers. You see that? Now, those are odd numbers. Let's look at what we call prime numbers. Let's erase and look at the prime numbers. P-R-I-M-E. Alright. The prime. Now, these are numbers. You can divide them by themselves and the answer is 1. You can divide them by 1 and you get the number itself. If you divide them by any other number, you will get an answer and a remainder. When you get a remainder, you say it is not divisible by that number. Example, if you say 7, or suppose you try 9. 9 divided by 2 gives you 4. You get a remainder of 1. Good. 9 divided by 3 is 3. You get a remainder of 0. But hold on. If it was a prime number, you will always get a remainder when you divide it by a number other than itself and 1. So this is not a prime number. Here you divide it by a different number. It wasn't itself and it wasn't 1, yet you get no remainder, so it's not prime. You're not supposed to get a remainder of 0. Let's try 7. If you divide 7 by 1, you get 7, no problem. If you divide 7 by 7, you get 1, no problem. But if 7 is a prime number, that means if you divide it by any other number, you will always get a remainder. This is 7 remainder 0. This is 1 remainder 0. Now, if you divide it by any other number, you must always get a remainder that is not 0. Let's try. 7 divided by 2 gives you 3, remainder 1. Alright. 7 divided by 3 gives you 2, remainder 1. Good. 7 divided by 4 gives you 1, remainder 3. Okay. 7 divided by 5 gives you 1, remainder 2. 7 divided by 6 is 1, remainder 1. So 7 is a prime number, because the only way you can get a remainder of 0 is if you divide it by 7 itself and divide it by 1. Any other number always give a remainder that is not 0. So 7 is a prime number. So a prime number is divisible only by itself and 1. You can divide and get no remainder only if it's divided by itself and 1. So 7 is a prime number. Let's list the first few prime numbers. Prime numbers. What are they? You have 2, then you have 3, then you have 5, then 7. Others are 11, 13, 17, 19. Those are some examples of prime numbers. 23, 31. Alright? Those are examples of prime numbers. Now, we have our last set of numbers. Composite numbers. What are those? We want composite. Composite numbers are not prime. They're composed of other numbers. You can multiply two other numbers and get them. Now, if we try 7, well, 7 times 1 gives you 7, but that doesn't prove that it's a composite number. It must not be the number itself, and it must not be 1. You cannot multiply two different numbers, two numbers that are not 1 and 7, and get 7. If you try 2 and 3, we will not get 7. Try as you may. If you try 3 by 4, you will not get 7. 7 is not a composite number. What about 8? Suppose you say 2 by 4. You get 8. 8 is composed of 2 and 4. You can multiply 2 and 4 to get 8. You can also multiply 2 by 2 by 2 to give you 8. So 8 is a composite number. You can multiply the composite number by 2 or more prime numbers. You can always break them down into prime numbers. And notice 2 is the only number that is a prime number and is even. Alright. So the 4 can be broken down into 2 by 2. So this is a composite number. If you try 15, how do you get 15? Let's see if we can get some prime numbers multiplied to get 15. 3 times 5 gives you 15. Good. What about Well, that's it. These are the prime factors of 15. About 30. 30 is 3 by 10. But we want prime factors. So 3 by 2 by 5. 3, 2, 6, 6, 5, 30. These are composite numbers. You can break it down into 2 or more other numbers to multiply and give you that number. So it's a composite number. So we looked at these numbers, these sets of numbers: natural, whole, integers, rational, irrational, square, even, odd, prime, and composite numbers. So, in terms of what's going on, that's it for this video.